Hello, everybody. Welcome to today's Ask Me session / hands-on coding session. This will be our ninth in the series and the second in our hands-on coding sessions. Okay, my name is Adjuno Christian. I'm the Assistant Program Coordinator and Data Scientist at Family. Just to confirm, I hope everyone can hear me clearly and see me clearly. You're all welcome to this session. Welcome, David, Joshua, Kizito, Temitope, Abiabuchi. Today's session is going to be a wonderful one and it's going to be much more insightful, especially to the data engineers and also the data analysts and data scientists too. They can also benefit from today's session. So our instructor for today will be Daniel Owolabi. He's a data engineer at Summer'22 AI Labs. So we'll be the one taking us for this session today. So without wasting much time, we didn't start in time. Sorry about that. Slightly late. He's having technical issues. So I'm going to invite our speaker now, Daniel Owolabi, who's going to take us on today's session. It's going to be an interesting one. So just try and follow along, and if you can follow along, this video will also be available on our YouTube channel, so you can go back and see to get the info. Okay. Daniel, can you hear me? Over to you now.
Hi, Christian. Can hear you. Thank you. Hello, guys. My name is Daniel Owolabi. I am currently a junior data engineer at Summer'22 AI Labs. And today's session is going to be on introduction to Kubernetes. So this session was originally created for the data engineers, the data engineering track, but it's like they said, it's everybody's welcome, and maybe you can pick up one or two things. I'm going to start sharing my screen now. I don't know if you guys can see my screen.
Yes, we can.
All right, thank you very much. So first of all, we need to set up our environment. When we are working with Kubernetes, there's a need to set up some things that we need for setting up our cluster and creating pods and whatnot. I know data engineers will understand all these jargons that I'm saying right now. Maybe data scientists can't. But so first of all, okay, I'm going to be working with VS Code today, so that's why you guys can see VS Code first. But this is my own local machine. So to set up, what do we need? We need, I was asked initially by Christian, you guys were asking what you need to set up to like prepare for this session. So first of all, we need Docker. That's the first thing I'm going to mention. You need Docker. If you are working on your local machine, okay, disclaimer, I'm not actually working on my local machine right now, but I'm accessing from my local machine, obviously. I'm working with a GCP VM. That is because I don't want any hiccups with this process, and my own local machine has its own constraints. So I'm working with a GCP VM. I have set up the VM locally for myself. And I think I went through your material again, and you were instructed there that you can set up a VM for yourself to play around with Kubernetes, set up a Minikube and all of those things. But if you haven't done that, you can work with your Mac, your Linux, your Windows machine using Docker desktop. If you're using Windows, I will advise that you enable your WSL feature on your Windows machine so that you can actually run Linux on your Windows machine. But if you're not using anything, at least 4 gig RAM, better still, 8 gig RAM, I won't advise you to do that. It is better you just run all of this on a GCP VM. You spin up a VM on any cloud provider. Actually, you can use Google, you can use AWS, you can use Azure. So right now, first of all, we are going to do an app update. So I'm working with the Linux machine, like I mentioned initially. So sudo apt update. This is the command that you use to make sure that your application installer is up to date and you won't have any inconsistencies between the distribution of the current Linux and your own Linux that you have currently. Then I can just press that. It won't do much for me because I already have it updated, but I mean, then sudo apt install. So we want to install Docker now, right? So we are going to do a sudo apt install so that if I do an apt install Docker, this is if you have not set up Docker desktop, right? If you are just working with a VM like I advise you to do, you can do this apt install Docker. It's not going to be able to do it. So you need admin privileges to use apps to install Docker in your system. So sudo apt install, Docker. So I am not going to press enter with this code. I'm just putting it there so that you guys can see, because I already have Docker on my own system. So when you install Docker like this on your system, I'm going to make reference to the Docker desktop again. If you have installed Docker desktop and you've enabled it for your WSL, you don't need to do this. So if you are doing this fresh on a Linux server or on your own local server, that is a Linux distribution, you can do sudo apt install Docker. And once you have done that, you need to add that Docker to your path. You need to add it to your path using this command right here. I know it's kind of boring right now, but we are going to get past all of this. So you need to add that Docker to your user path. So you do a sudo user mode -ag. All these commands, I won't say that you should cram. You don't need to know them offhand. You can legit just go to Google, type how to add Docker to path and all of that, and you get a good response. So when you have done that, now you need to install kubectl, because the whole point of all of this is that we are trying to work with Kubernetes cluster. And to interact in a Kubernetes cluster, if you have gone through that material that you are given initially, you need a command line interface, or you can use your web server, or I think the API or something like that. So kubectl is the CLI tool for interacting with kubectl is the CLI tool for interacting with your Kubernetes cluster. So for this, I am actually just going to do it now, that installing, so that you people will know that we won't think that this is something that, I mean, where is it getting all these commands from? Okay, no, I'm not going to use these random guys. I'll go to the actual Minikube documentation. So I want us to cultivate an habit. Don't deprive yourself of the information that is available and that they have made open source. Do we understand? We have Minikube websites here. The documentation is here. If you want to install and set up, they've put all the commands you need there. This is install Minikube via direct download and all of that. So now what I need is kubectl. They've already said here that if you want to install Minikube, then you need to install kubectl first. I'm using Linux, so I'm going to go with that. Install and set up kubectl. I don't know why they are giving me Chinese and English. So yeah, you can do a call to install this particular file. This is taking longer than I thought it would, so, but like, because this is not where we are going at all. So you can install that. once you have installed it, you will see it here. This is kubectl. Can we see? I don't know if, are you guys still following me? I just want to know that you guys are following me.
We're
Hello?
with you, sir.
All right,
We're with
thank you, Joshua. So we have kubectl right there. Now, kubectl, with that kubectl, we are going to add kubectl to path so that we can execute it. Because right now that you have downloaded kubectl, you can't just type. It's not, I can't demonstrate it right now because I already have kubectl. If I type kubectl, it's going to work. And that's because I've installed it before. But to make it work like I have right now, you are going to convert this into an executable. So you are going to do a chmod plus X for kubectl. So if you check it again now, you will see that it has turned green. That means that it is now an executable and you can now use it. But it is not, you can only use it in this particular folder. To be able to use it anywhere in your path of your entire machine, you need to add it to path 2. And that is moving it to your bin folder. I don't know if you are familiar with the bin folder, but if you are not, it doesn't really matter. You need to move your, like I said, all these commands, I am having a bit of a constraint right now. Can you guys give me like 1 minute?
Yeah, sure, we can.
Actually, someone is knocking at my gate and I need to tell them that I'm busy. So give me 1 minute.
Okay, yeah, sure. Before it comes back, yeah, I hope for what he has done so far, we understood to this place he is now. If you don't understand, yeah, those in the data engineering track, they know about the material I was talking about, this mini cube, what to install and all that. So, but as it's explaining, you get to understand more. So just try and follow along. If you don't understand now, and go back to this video. This video will be available on our YouTube channel, so you can go back and follow along right to code. So let's just give you a moment time.
All right, guys. So you are going to move. It's actually on this page 2. So move the binary to your path right here. So you move that particular kubectl binary to your path, and then you can check the version. I will check the version of my own kubectl too, right here. Kubectl version. Oh, okay. It can't work yet because I don't have my Minikube up yet. So now, once you have done that, once you have installed kubectl and you moved it to your path, the next thing for you to do is actually to install Minikube, which is the main reason why we came. Can we guys still see my screen? Are you guys doing it?
Yes, please, we can.
Please follow me. I know this can look very boring, but I need to do it for the sake of anybody that wants to watch this video again and they want to set up. So you're going to call into the same thing we did with kubectl. We're going to call Minikube to use the call command to get Minikube on the machine. So and as you can see here, instead of running it twice, they've used the double ampersand command to run 2 commands together. So you can do that, or you can just delete it, and like we did initially, we just downloaded kubectl first, then we made it executable. Here it's going to do both of them at once. So if we check here, we'll see that Minikube is right here. This particular Minikube, we're going to move that Minikube to your path so that it will be executable. So you will run these commands and you will be up and running. So once you have that, I have Minikube already added to my path, right? So, and that's why this can work. Once you type any of these command line tools, kubectl, and you press enter, and it gives you all of the options that you can have for running that particular command on the command line, then you can be assured that it is actually working. So the first thing I'm going to do after setting up is we're going to do a Minikube start. So what this does is that it's going to pull down a Kubernetes image, I mean a Minikube image, anyways, on your local machine. When I say local machine now, I mean the machine that you're working on primarily. So it's going to pull down Minikube on your local machine, and then it's going to prepare Kubernetes for it, and it will be using the Docker as the driver for it. You don't need to understand most of what I said right now. The gist of what I'm saying is that Minikube is going to be pulled onto your local system. So you wait for this to complete. So while this is running, what I want us to actually walk through very fast, we are already 22 minutes in, so I want us to walk through converting just a very simple notebook into what do you call it now? Into a script. Because I feel like the idea I had before was just that we are going to just deploy. I would have made an image. If you don't get what I'm saying, you understand you should. If you're in data engineering track, you should understand what I'm saying. If you don't, just please follow along. We're going to just what I planned initially to do is just push a container for the script for this particular workflow to a Docker hub, and then we'll just deploy it on the cluster and interact with it, play with it, see what the concepts like pods, what do you call it now? Deployments, replica sets, what all those things mean. I mean, it might seem very abstractive when you're just reading it without doing it. But I just made up my mind in the last minute that why not just create a very, very simple application with something that we are all familiar with. So let me see. I think Minikube should have started already. So yeah, great. Let's check Minikube status. So everything is running. My kube config is running. My API server is running. Kubelet host the type is a control plane. So what's Minikube? Minikube is a standalone cluster. I know we have gone through I don't want to go through all those concepts. We have that material, we can go and read up. But basically, just to give little insight into what we're going to be doing today, we're going to be working with a standalone cluster, not the full-blown cluster. And this is just for development environments, for understanding the architecture of Kubernetes and how most of all these things work. So now my kubectl version should work now. Yeah, so yeah, we have the client version is version 1. We don't really need this anyway. So now kubectl gets pods. I think we know what pods are. We don't have any pod running in our namespace right now. And a namespace is an abstraction for delineating, for separating different teams. Perhaps say we have two teams. Some teams are working on the front end of an application. Some teams are working on the back end. So we want to separate those two teams, and they want to be able to interact with this same cluster. We use namespace to delineate them. It's like giving privileges to those two different teams, but the work of one team won't be able to affect the other team. That's the whole point of a namespace. I shouldn't be explaining all these things right now. You guys can go and read it up. So what we have here is just a simple module. I mean, we import our libraries. Sorry, let this run. This is, I want us to be very fast with this. So if you look at this folder that I am in right now, that's the folder. Let me show you from the command line here. If we are in the data engineering track, you need to be very comfortable with the command line. And because that's where you'll be running most of your things. So we have introduction to Kubernetes here. If you want to follow along or use this particular example that I'm using right now, you can go to my GitHub and clone it. Let me see. I hope you guys are still with me. So are we with me? Are you guys following?
Yes, we can hear you.
All right. Okay. So this is that particular folder that you guys can clone. You can just go to Daniel Tomiwa /introduction to Kubernetes and clone that particular GitHub. I don't know if I should post this in the chat group. Coming. Why is Zoom running away from me? All right. So I've put it there, and you guys can clone it and follow along if we have time enough for you to keep up. I hope I'm fast enough because I need to be fast with this because we still have a number of concepts to go over with Kubernetes itself. This is not the main goal. So this, we are importing the data sets. This is the data that we are going to be working with. It is basically a taxi trip data set. Do we understand that? In the sense that so taxis travel from places to from points to points, and they've gathered data sets for the trips of taxis for a particular year. This is 2021 January, and we have the time, pickup time, drop-off time. We have pickup location, drop-off location. I'm intentionally picking out those because those are the columns that we're going to be working with. We're not doing a full-blown data science work of finding the best feature or best model now. We just want to deploy this particular workflow and be able to interact with it on our Kubernetes cluster. So I read my data set with this particular line of code. It is a Parquet file. There's nothing wrong. There's nothing new here. That folder contains a Parquet file. A Parquet is a different type of file for saving data instead of a CSV file. We can Google that. Then in this line, we are subtracting the drop-off date time and the pickup date time to get a duration. Because I mean, right here, we have a date time colon, right? And we are subtracting both of them to get a duration for that particular trip. And that's going to be our target variable. We are trying to predict the duration that a trip is going to take. So here we perform some conversions because this date time is we get the total seconds of that particular, each of them. That's why we're using the lambda. I think we should know how this works. And then this 60 seconds, so we convert it to a minute. So we are making sure that that target variable is in minutes. I'm very sorry that I'm brushing through all of this. This is not, we drop some part of the data. And then with this, for the particular example, like I said, we'll be using the pickup location, drop-off location, and the trip distance. So I called the drop-off location and pickup location categorical variables because they are actually categorical variables if we look at it here. I mean, this is like, these numbers are not necessarily indicating value. They are indicating points, like maybe latitude or longitude to something like that. I'm not very sure about it right now, but like that's how it is for this particular example. Now, the disk vectorizer here is going to convert. Disk vectorizer should be seen as your label encoder, your one-not encoder. It is converting each one of your entries into a code that a machine learning model can be able to use to train. But in this particular example, disk vectorizer does this for both categorical variables and continuous variables. So it is smart enough to be able to leave integers and continuous variables, but then for categorical variables, it's going to convert them into such a way that we have a dictionary for, say, we have this particular row. For row 0, we have a dictionary that will say vendor to LP pickup date time is going to give this value for it, like that. If we don't understand, we can research on that later. So let me just run all these cells, right? Show that it is working. We get the mean squared error, the data frame. We read the data frame for the data train, the validation, the length of the data frame. Sorry, I think I should run this first. And then we have this. So the target is the duration, like I said. The train is data frame train targets. Okay. Yeah, this is still the target, right? And this is the validation target. Then we have our model. We define our model here. we train it, and here we pickle the model, right? I'm sure we are. I don't know if we have taken courses before or anything that you save models using pickle. Some people use Joblib. You can use anything you want. So here we save that particular model, and the model will be saved in this models folder. So we have our model already. So now let's just go and convert this into a script. To do that, I don't know if we see this particular interface. Can we see everything that is here?
Yes, please.
Yeah, you can. Okay, great. So right here, I'm going to do something first. I don't like that I'm saying make detail and make cube. I mean, they're already there. So what these are the. Let me go into the introduction to the repo that I asked you to clone. So okay, sorry. So right here, we have the IPYNB file, but this is where we have the model. So why not just the best practice is just when we're going to be using Flask to expose this model, right? Flask is a framework for developing web applications. I'm sure we are familiar with that. So I'm going to quickly say make directory web service, right? So I should have that there. This is the web service, change directory web service. So there, right there, I'm going to create a file. A Python script, right? I think we can see the Python script here. This is the predict.py file. So with this in this file, this is where we are going to start working with our model. The first thing that I want us to do is to import that model. So let's quickly go back to our IPYNB file. We saved it, right? We saved that particular model as a pickle file. So I'm just going to quickly copy this command, put it in the predict.py file, like this. It is complaining that it's not seeing pickle, so let's quickly import pickle, right? So we are opening that model, but I'm saying I want to open that model, but the model is still in the models folder. So what I'm going to quickly do is come back to my command line, print the working directory so that I can get that particular directory, copy that directory, change directory back to the parent directory, change directory to the models directory. Okay. Then I'm going to move lean to the folder that I copied right now. Okay, then I'm going to go back to web service, right? It's just a folder. There's nothing serious about this folder right now. It just contains an empty predict file and the model, the bin file that we pickled. So we are going to, before we start working, I want us to note something, that when you are developing an application that you want to deploy, it is very important that you take note. Of course, we have libraries of different versions, right? So usually you create a virtual environment that you want to develop in, right? That you want to develop your application in. This thing is taking a long time, but I just follow. I hope we get to a good point out of what I planned on working on today. Okay, so like I said, you need a virtual environment. There are different virtual environments. There is virtual env. There is if you don't know what environment means, maybe you can Google it eventually and then come back to this video to follow what I'm doing. So today I'm going to be using pipenv. I already have pipenv installed. So that's why it is, like I said, when you are interacting with these things, you can just type that particular command and you bring all the options and all those things that you can use to interact with it. And That shows that you have it. But if you don't have it installed, you can do a pip install pipenv. Pip install pipenv. This is supposed to be a virtual environment abstraction for packaging our entire development library so that they will be consistent with what we are deploying. Because the issue is that one thing that can even happen is this pickled file that we have in this particular place right now, it is very possible that it was pickled with, because pickle runs on sklearn, it was pickled with an sklearn version of maybe 1.1.2 or 1.3, and then you are trying to load it with an sklearn version of 1.0, then it's not going to load it, and you'll be like, okay, what is going on? I saved this model, but to have consistency, you need to use pipenv. So one thing I'm going to do before I load this model using this particular predict script is I'll go back to my duration.predict file that I have here, and I'll check the sklearn version. So I already did it initially because when I was preparing for this particular session. So you do this, and it shows you the particular sklearn version. There is another command that you can use, which is pip freeze. Pip freeze shows you all of the libraries that you have and their version. So you can get that particular version from there too. But right now that I know that particular version, I'm going to say, and now pipenv works in such a way that once you have it installed and you enter a particular folder and you do a pipenv install scikit-learn, right? Equal to, it was 1.1.1, right? And we want to deploy this particular application using Flask. So I'm going to install Flask 2. Pipenv install. Note, I just entered this particular folder and I'm using that pipenv that I installed for packaging my environment. So pipenv install scikit-learn 1.1.1 Flask. I want to use Python 3.9, because that was what I used to develop this particular notebook. So Python 3.9. I think this should work, right? Okay. Coming. Yeah, this guy should be double equals. Okay, coming. I think, okay, there might be a situation with this particular folder, right? So what I'm going to do is I'm going to make another folder. Let's call it Flask app. Do pipenv install. So yeah, it was that folder. I think I might have messed up something in that folder, but if you have a new folder, I had that folder running before, so I cleared most of what's there so that I can show you guys. But I guess what I did might have messed up with the way pipenv is working right now. So now our new folder is Flask app, so we don't need this web service again. What I'm going to do is move copy that particular module and let me just use the command line. Print working directory, copy that. If you are following me, change directory. So change directory to introduction to Kubernetes. change directory to modules, right? And then in modules, we have as capital. In modules, we okay, I think I already moved it the previous time, right? So I need to move it. Sorry for all of this, but I think you should understand. It was in web service, right? So web service ls, I have that model there. So I'm going to move that particular file to the folder that I created for this particular Flask app, change directory Flask app. So we have this, we have the model, the pip file. This pip file right here, let me show you Flask app, the pip file right here. Once you use it, it's going to put all of the things that you installed there, and it's not working as I want it to right now. So I'm going to find that and install. Does it have SQL in there? No, it doesn't. All right, so pip env, I would have installed it together, but since it was deciding to be Flask, still running. So yeah, the point I was trying to make initially, right? There's something that I did that I hope I won't have to repeat all of these things again. But so this pip file lock is going to help you to create hashes for all of those libraries that you're using in your development environment so that it can be transferred to the deployment environment. So this pip file should contain here scikit-learn Python 3.10. I didn't specify the Python version. So it is very important. So what I'm going to do is I'm going to quickly create another. See, I hope you understand what I'm trying to do anyways. I'm going to create another application, another folder, call it make directory Flask application, right? So I'm going to do a pip install scikit-learn, like I wanted to do initially, Flask, then specify the Python version to be 3.9 because I worked with 3.9 and I want that library to be consistent. So it is installing scikit-learn for me. What I'm going to do is that in that particular, I'm going to delete this, right? And then I'm going to delete this web service too. So it's installing all of the required packages that I need right now in that particular virtual environment so that I can develop with it. And when I am moving this into production, I won't have any inconsistencies. Change directory. Oh my God.
The bin file, you move to that folder. I just deleted it with it inside.
You said?
That bin file, something .bin, something you move to into that that app. That file folder I just deleted. I didn't copy it out.
Well, in fact, I just discovered that I ran the pip file and pip file log in my introduction to Kubernetes. I'm very sorry for this. That's live coding for you. I think I am on my feet. So what I'm going to do is I'm going to run all of these cells again. Right? So I should have the model here. Yeah. So yeah, can't believe this is taking this much time right now, but please just bear with me. I think you should understand. Go to models, right? Change directory, models, right? And then move this particular bin file that I want to deploy to that directory, but it's not called Flask app again, it's called Flask application, right? So I can change directory to different directory, change directory to the Flask application. Okay. So we have this there. So I'm going to run the pip-env install in this particular folder. This was supposed to be done like 3 commands ago, but bear with me, right? So it's going to package all of that. I want to delete this pip file lock that I have here and pip file that I have here too. So now we are still in our Flask application folder, and how come those guys are not there? This is even not that important, but I mean, I want to do it because I don't want any inconsistency when I try to deploy it on the cluster and it's not working as I want it to work. Okay. All right. Well, I think we are ready to go. It's almost like we just started. This is going to take longer than I anticipated. Anyways, one thing that we should do right now, we have the files that are helping us lock our libraries, and we have that particular bin file that we saved. So right now, I'm going to make that Python script that is going to do the prediction itself, predict.py, right? So let's work with that particular Python script. To make this very fast, well, let's go to did I delete the what do you call it now? The IPYNB file. I think I deleted the IPYNB file.
Yes, you did. In that folder, in the other folder, you deleted.
Interesting. Well, what I'm going to do is I still have it on my system here, but I can just git fetch coming. Okay. It wants me to. Okay, let me do something, right? Blue. So I'm going to git clone my repo again to this particular place. So I have this new. This is it, right? So let me quickly go to that Flask folder. This is very messy. Change directly with Flask. So print working directory. I want to copy this. Then I want to run this guy to have that bin file saved in the model. So has it saved? Let me see that coming. We have the new. Okay, it's couldn't have saved because I don't have this particular model folder created. So I'm going to new folder models. So I'm going to run this again. Okay. So we have this model, right? Let's go there. Yeah. Yes. Change directory. Change directory. I think it's in the new. Direction models, right? And then I'm going to move this to that Flask application. Then let me go back to the Flask application folder. So I created this folder to build the application. We have the link, the bin file. We have the predict.py file there. In the predict.py file, we want to import. Where is that new? Okay. Yeah, we want to import this model in the predict file, and then import pickle here, right? Because in this particular folder, we don't have it, in the Flask application, we have it called lean reg bin exactly. So, and we are not writing to it, we are reading from it. Let's call it fin. Pickle.dump. If we check this particular place, when I was dumping that model as a bin file, I saved both the vectorizer that I was using to get all those features as like a dictionary to dict here. I saved that particular vectorizer and the model itself. So where is that pickle.dump? Yeah, this dict vectorizer and the model. So we need to load both of them, right? Okay, sorry. So let's call it vec. No, let me call it dv and model, right? Equals to load, because we are not dumping again, we are loading that bin file. And it is just the f out, f in, right here. So after loading that model, we want to use it to predict. So let's have preprocess. We preprocess with that particular vectorizer. Let's have predict, right? Okay. So what do we need from preprocess? We want the features from the right that is going to be passed into here. So we want features defined as a dictionary. Then what I'm doing right here is something that was done here, because whatever thing you do to your data when you're preparing it for the model that you're training, you need to do it when you're predicting too, because it needs to be in the same way. The model needs to perceive the data in the same way. So before we trained this model here, we did something here that, okay, we combined the pickup location that is a categorical variable and the drop-off location into one. So I'm just going to do that. I like this example to show that whatever it is that you are doing in your training process has to be done in your predict to the data that you want to predict. In production anyways. So now we have the features, and I want to, let me quickly go back here, right? So I want to set this particular feature to be the right. The right is going to contain dictionary of this, and then but I don't want to use this method because this might complain. I've tried it before. It will complain that it can't add. This were numeric values, and this is a string. The engineering that was done is that it is combining the drop-off location and the pick-up location into one single variable to make our model better. So it's just to show me doing what I'm doing in the training in production too. So we're going to convert this into a string. Okay. I think we are familiar with formatting. So what I'm doing here is that, okay, let me get that right. Pick up location, drop off location is converting it into a single feature, which is pick up and drop off, right? So what else do we need to do that we did initially? The distance, we need to get that particular target. I mean, we are using two different, if we come back to the notebook, we have numerical and categorical, right? I think it's somewhere here. So we are using the pick up location and drop off location and the trip distance that we have in this particular data to do our prediction. So I want to get that trip distance in the predict.py file too. So features trip distance is equal to get this from that ride dictionary. We have trip distance, and then this particular function has done the pre-processing that we need. It has engineered the features, gotten the trip distance in the :2. So we can return features from this particular function, right? Now, for the predict, we are going to pass in the features that was returned. And we are going to use this vectorizer to convert it into a form that our machine learning model likes. Transform the features, right? And then predictions is going to be model, this model that we imported from that pickled file. You know, I saved them, I saved both the vectorizer and the model together. The model dot predict, right? X. And then we're going to return read. So one thing I want to quickly do is, let's go to, we are working in the repo, right? Introduction to Kubernetes. What's going on? Okay. Actually, what's wrong with my typing today? Change actually fast. Right. So I'm going to create a test file. To confirm that this whole thing that I'm doing is actually working before I even convert it to a Flask application. So let me go to my test file. So since I'm in the same folder, I can import this predict file in the test file. So in the test file, I'm going to import predict, right? And then I'm going to the ride that we are predicting. Like I said, it's going to be a dictionary, and it is going to contain pickup location, drop off location, okay. and trip distance, right? Those are the three that we are using. I didn't know I didn't know the consistencies in this capital, and that's why I went to copy those ones. But I think trip distance should be straightforward. Trip distance, and we have this. So let's call our pickup location 10. I mean, it was an integer. Let's call this maybe 50. Let's call this maybe 40. There's an inconsistency somewhere. Okay, here we have this. So yeah, that's our ride that we are trying to predict. And then I'm just going to the features. We process is a variable that I'm saving predict dot to come back to my predict file. Here I have a preprocess, right? So I'm going to copy that preprocess read. So I'm pressing the features first, then I'm going to predict it. So the prediction itself going to be predict dot predict, right? Because I think that's what I called it in that particular folder. Predict features. I don't see the point in copying it again. Yeah. So processed, right? Then we're going to print. Are you with me, please? Is anybody still with me?
Yes.
Yes, please. Yeah.
So print prediction. So now I'm going to test out this test script. So Python. So before I run this, right, I created this virtual environment. There's a virtual. Don't look at this. This is my own Conda environment. That's something else. Say I did not have this environment and I created a particular virtual environment. I'm just going to say pip-env shell so that it will bash into that particular virtual environment that I created in this folder. So that all the libraries that I installed in this virtual environment will be available for me in this shell. So as you can see here, it is calling it the Flask application, which is the name of this folder right here that I created that virtual environment in. So it's saying that I'm running using this kernel for development, and I'm still in this folder that contains all of this. So the Python that I'm going to be using is the Python that I installed when I was running this command that kept giving us the YASU. We're doing it when I was running the pip-env install 3.9. So we need all those things to be consistent. That's why I'm making emphasis on them. So Python test.py. Let's see if it works. So yeah, it works. We have the prediction. This is the prediction from that particular model. This model that we have loaded in this predict file. So I'm just using this to test this particular logic, all these functions that I have here. So now that we know that it works, one thing that we are going to do, I don't even like that this is a list. So I'm going to come back here and say to return is 0, predict 0, and then so that it will just return the number. So yeah, let's turn this into a Flask app. First thing that we need is to import Flask. I need something from Flask. Import Flask. Request personify. Okay. I think eventually I'm going to be using OS, import OS. Even not now. Let me just import it now. So yeah, let's
Please change your first import to from so that you know have errors.
Oh yeah, thank you. Flask import Flask request personify, and then the app is going to be equal to Flask. Let's name our application duration prediction, right? So now I'm going to create the endpoint that is going to, the function for the endpoint that is going to do this. First of all, I want a home. There's a reason, I don't actually need it, but I want to use it to demonstrate some things when we start running what they call it now, it on Kubernetes. So let me get this HTML. It's going to format it as a string. So this is just simple HTML file h2. See, we have h2. So this thing what we do, thank you. Okay, for now to the home page. Right, so coming. So return HTML. Specified here. So this is, like I said, this is not needed, but when you're creating your Flask app, you need to decorate it to show that this is the endpoint. When I'm interacting with this particular application, is going to route me first to this folder, to this function when I come to a particular endpoint that I'm going to define with this decorator. So app.route. So since it is the home folder, it is the home endpoint that I'm going to specify here. Another thing that we need is the actual prediction for predict endpoint, right? So what do we need? We have already defined our preprocess function, our predict function. So first of all, let me decorate it like I did the initial one. That now, instead of routing me to the home folder, I want you to route me to the predict endpoint. I said the home folder. The home endpoint should route me to the predict endpoint. So when I'm trying to eat this application when I start with you are going to understand we are going to have to attach this to our address. So what do we need from this function? We need it to first get, we imported a request for Flask. This request, this particular request function helps us to get whatever thing is eating this endpoint. In any case, this when we come to the home folder, is going to display this on our page, right? But this is going to be, we need to specify what kind of request that we want to route to this predict endpoint in this place. So it's supposed to attach methods that are allowed to this endpoint to be, so we are going to be sending a request. So it is a post endpoint, right? can go and research more on CUDA operations. That is, if you don't know about it, JSON payload will now be equal to that request that we're getting from that endpoint dot get JSON. And then we have what else? We want the features, right? From this part. So it's going to get the payload that the client is sending to this endpoint. And then we want the features from that part. We want to prepare the features with that payload. Prepare features, JSON payload, and then we are going to predict it, right? Predict. Let's go to okay. Process, then predict. Those are the two functions that we have. So predict with so now, when after predicting, we need to convert, like I said, we have been using dictionaries. Yeah, we tested this with the dictionary. It is good to do this because when you are creating servers and when you are working with backend applications, it is better that you put it in a format, in a dictionary format that can be easily converted into a JSON object. So that's why now whatever it is we're going to be receiving on the web from this is going to be a JSON payload. And now we're going to convert our prediction into a JSON format object too. So so we have read is equal to let's call it prediction JSON, right? Is equal to like a dictionary that is going to be, so we have the, what are we predicting? Like predicting a duration, let's call it duration, right? And say this is the predict that we predicted here. So you should return this prediction JSON. But before we return it, we need to use this JSONify so that it can send. Okay, so we have that. What else do we need? So this is our script. This is the home. This is the actual function that is predicting it. It's a post endpoint. Now we are going to put condition if name equals to want it to debug when we change anything in our scripts. We are running it on this local host, right? So, and the address for your local host is always 0.0.0, 4 zeros. I think these are 4, right? And then we want to run it on which port? Port 80. So yeah, we have created a Python script for this particular notebook. So there are some inconsistencies, but it is because my coming. my environment is not, my VS Code is not detecting this particular environment. But let's hope that, because what's the problem? You're saying that expected. Okay, yeah. All right. So yeah, let's test this out. Let's test this out using that same test. So all these that I imported here, they are for Flask to understand whatever it is they are routing to it using this predict endpoint. So after saving that, I have specified in this particular script that when I run this code, it is supposed to run on my local host using port 80 of my local host. My local host is my machine that we are working on right now. So now I'm going to do something here. So I have that particular predict file. So I'll say Python predict.py, right? Oh, I didn't save it. So let me run that again. Come in. Did I specify my app? Oh, I did not. Coming. Post endpoint predicts post log. Coming, there's something wrong. I mean, 1,000 instead. What was wrong with that port? There was something wrong with that particular port, so I don't understand. But that's fine. So this, I was running it on 80 before and it was not running. So it is now running on port 8000. So what I want to do is test that particular script, this script that I created using a Flask app. And what I'm doing right now is that I am serving this app on my local system. So if we go to your web browser, I'm coming, localhost 8000, right? We are running on 8000. So we have this. Welcome to the home page for Jury show grade prediction. So it is actually running on our machine right now. That's what is going on. I don't need to test it with this test script again because I already confirmed that with the web browser, but I can do something import requests. So this is a library that comes with that you can install to send JSON requests. So instead of doing this now, what I am going to do is, before we were just running it inside our machine without even saving it anyway. But now it is active on port 8000. So I'm going to send a URL request to that particular port for the prediction. So that I can show you guys these predict features. I mean, this particular endpoint. Are you with me?
Yes, please.
Yes.
I need confirmation that you guys are here. Okay, so we have HTTP localhost, right? What port is it running on? 8000, right? And then we are routing to that. This is what I was talking about, that we want to send a request, this write request to this predict endpoint. So our response from Flask is going to be equal to request dot post. Is a post endpoint, right? The URL that we have defined here, and the JSON is equal to this particular JSON prediction. So we're now going to print on our command line interface the response, because Flask is going to send us a JSON object to .json, right? So I can just delete this. And so I'll go to another terminal. Like I said, the debug through just okay. Did I change anything? That's fine. I'm going to go to another terminal. In fact, I can just come to the main terminal here. Change directory, introduction, right? Kubernetes, change directory, Flask, application. So that's the test file. So I will just run, first of all, pimp env shell in this place, because env shell bash into the, oh, sorry. The pip env is not available in my default. Why is this thing? My network bad. Activate my env. Not this particular. So env shell. So I'm going to run that Python, which I actually don't even have to come to the PIPM, that particular development environment to do this, but I mean, test.py, yeah, I shouldn't have done that. I think to explain what just found, this request right here, I was running it inside the shell for Flask application, which was not what I was supposed to do. This request library, I didn't install it when I was doing pipenv install, right? For this pip file lock and pip, so that's why I did not see it. But right now, I've come back to my own. I think I have request in this particular my default environment. So I'm going to run that Python test. I used in hanging. Exit again. Come on. This is taking longer than I want, so I'll just type it. something is wrong with my network. Because I told you guys I'm working on my VM, right? So on the GCP VM, Python, test, although you can do all of these things on your local machine too. It's basically the same thing. That's not actually. Okay. Where is that test file? Okay, what's request? So this is supposed to be request, right? So that was a mistake. You make a lot of mistakes when you are coding, but just read the.
Expected is normal.
Why is this thing hanging and frustrating? Exit. I'm using, it's my network that is messing up like this. I don't know what's wrong with anything that is making me have to do this. Okay. It's not giving me what I want. Python test by JSON code error. Code error. Okay, let me see. Test. We are spending most of the time. Oh my God, how long have we spent? Request was post URL. Let me run another bash. I think what I'm going to do eventually is, if this test is not working, I'm going to leave it for now because this is not where we are going, like I said. My network is really messing up this whole session. Change directory, introduction, Kubernetes, ls, directly last application, ls, then we have Python. Okay, yeah, same thing. So line 14, int response.json. I'm coming. There's something wrong. I can't tell what is wrong right now, but if I spend all the time debugging it, it's going to, it's not going to be funny. So what I am going to do right now, we can see that it was already working here, right? So let's go ahead and just Dockerize it because that's the whole point of all of this. So we have created a script that is working. I don't know what is wrong with this network. It's not supposed to be taking this much time to run all of this. In any case, so I'm going to go to, let me stop running this on my local system. Get oh my God, this is where the problem is. Flask did not get what I wanted it to get because I didn't put that particular underscore. Can you imagine? In any case, let's see if it works now. Actually. what's wrong with this network? Python test.py. I'm not in that directory. Change directory, introduction, right? Change directory, Flask. I think it's called Flask application, right? Okay. And then I can say Python test.py. Yeah, there. That is what we were expecting for it to predict, send us that JSON prediction. So now that we have confirmed that this is working, we are going to stop this and go to the main. I can't believe I'm just saying this. The main goal for today, which is to create a Docker container and push it and run this whole particular microservice on the Kubernetes cluster. So we have this folder, we have all of these files. I'm going to create a Docker file, right? I don't like that this thing is glitching like this. It's really okay. Should appear here. So if you have Docker linting or Docker extension installed in your development environment, it's going to recognize it, and you can see that it is that's put there that this is a Docker file. So we are going to, what this Docker is doing is that all of this application that we have in this folder right now, we are going to package it into a single entity, which is going to be an image. I'm sure data engineers, you must have read that an image is a binary or representation of an application and all its dependencies. So all of these dependencies that we have packaged, we are going to use a Docker file to make an image out of it. One thing I told him to also tell you when you are asking questions about what you need is that you should create a Docker Hub account. Docker Hub. If you put Docker Hub here in Google, I'm not sure if this was in your, how bad is this network? Jesus Christ. So in Docker Hub is a place that is like a repository for images. As we have repository for code, we also have repository for images, and that is where most of all these major application and software providers, open source software, deploy the images for their software. And one thing about Docker files is that there is no new Docker file that is starting from scratch. We are going to be starting using the image of one of all of these guys. So since we are working with Python, I have decided that we are going to be running it from a Python image, Python. I think I was running 3.9, right? Python 3.9.
Yes, yeah.
Did someone say something?
Yes, I said yes, you were on 3.9.
Okay, yeah. Thank you. From Python, so we are going to run, first of all, look at this Docker file like it is a container. Look at the container like it is a new system that you are now deploying this application that I was running on one port on my own local host here. So we're now going to put all of this logic in a new system, like a brand new system, and what do you call it now? Install all of these dependencies. So what I'm going to do is run pip install. It should upgrade my pip so that I won't have any problem. Then it should also run. You know what? To save time and let us get to Kubernetes. I already have that Docker file somewhere on my system. So let me quickly copy it. I'm coming. Then I'll explain everything. Okay. So we have run pip install, upgrade the pip, run. We are telling the Docker file, this Docker file, it is through the Docker file that we are telling that particular container, which is going to be like a new system, like I said. I mean, you can call it anything, but that is how I understand it. To run pipenv, like I said, we're using pipenv in our development environment. So now we are using pipenv here again. So this work directory is going to create a new directory app in the root folder for that new system that I'm referring to. I'm just referring it to as a system. Just when I say new system, know that I'm talking about a Docker container. So I'm going to copy all of the files here. So what this command will do is to copy the pip file, the pip file log, into the current directory. When you use work directory command in Dockerfile, it creates that folder and change directory into it. So we are currently in the app folder. So we are copying everything that we have in this Flask folder to the current directory, which is app. And then we are going to run pipenv install as because I'm using pipenv is why I'm doing this. It really doesn't matter if you are using pip. Everything that I'm saying with pipenv, know that you can run with pip. The only reason that I am using pipenv is to keep that. I mean, I might be lucky and use pip install, and then there won't be any inconsistencies in the library. But to be sure, and not to have to be solving errors that you don't need to be solving, use pipenv. So we are going to be installing it as a system, and we are setting it in a deployment environment. So we copy this script that we know that is working now. We are going to copy it inside this Docker file. And that folder, I said that folder, that particular module that we are using to predict, we'll copy it to the current directory, which is also still the app. And then we are going to be exposing port 80. Should I expose port 80 again? Port 80 has scarred me, so I'm changing it to 8,000. So expose port 8, it actually doesn't matter. Because I mean, this is a new system, like I said. Whatever thing I messed up here is not going to be affecting my Docker container. So this is going to be the entry point for our container, as I'm saying that is an abstraction. In that container is now going to run Python. When I wanted to run this particular application here too, I had to say Python predict.py, right? And then it run it. So here too, we are going to say Python predict.py. So it's going to be running that particular Flask app on the container. This is what this file is going to do. So what I'm going to do now, that once you have your Docker file and you have it saved, ls, okay, I'm there, we have my Docker file. So there's a command that says docker build -t, docker build this current directory. It is smart enough to find this Docker file. This particular command is going to find this Docker file in the current directory that we are creating our application from. And then I'm going to tag this image Danny Tomiwa / what should we call our image? Let's call it duration. Oh my God, why is this thing taking time like this? Prediction. Let me call it duration app, right? So Docker build in the current directory, tag it Danny Tomiwa. Why am I tagging it Docker? Why am I naming it exactly like this? It is actually this name that I need, the duration app, but I am calling it Danny Tomiwa here. I already have my own Docker orb registry set up. So I'm going to sign in. The network is terrible. I hope this was not a waste of you guys' time. Are you guys getting one or two things?
Yes, of course. It's never a waste.
So yeah, we have this is my own Docker registry, and I need to call it the name of my username plus the name of the app before I can push it to this registry, because I need to push it to this registry before I can pull it in a Kubernetes cluster. So now that's why I'm naming it this. So I'm going to build this particular application now. So it runs all of this. Can we see? So first of all, the first step, it's updated pip, run pip install -u pip, install collected packages, then run pip install pipenv, all of these things that I have specified in the Docker file. It is running it for me to package it as an image that I'll push to a Docker registry. All right. It is still running. So one thing that we are going to do is after we have, okay. So now that it has done that for me, I can say Docker images. So what I have here is the Python that I used to create the image, and that particular this is my own app that I have made a container into a container image, into a Docker image. Anyways, this is it. This image right here is the image that was pulled when I ran Minikube stats earlier on to run Minikube on my local PC. So what I'm going to do now is that I have that particular Docker image, right? So I'm going to run the image, Docker run. Note that I don't have, let me confirm to you guys that I don't have, this is the test.py, right? I don't have that Flask app running on my own local system again. So let me run that test.py to show you that. You see? Okay, sorry. It's not going to do that. It's not going to run because I'm not saving anything, right? Connection refused, failed to establish a new connection to that particular. I'm not running anything. So what I'm going to do is that I'll come back to this particular terminal and run that image that I have just created, Docker run, and I am going to port forward. We are running, I specified here, let me see. Oh my God, I might have to rebuild that image. I think, yeah. This port that I am deploying my application on has to correspond to the port that I am exposing on my container on that new system. Because the only reason that one worked the other time is because it is on my local system. So I'm just running that port directly. But now on this new system, which is the container that I keep calling new system, I am saying that I want to expose port 80. So, and since it is its own entity, it is not exposing any other port. So if I'm running my application on port 8000, it's not going to run, except I expose port 8000 here too. So let me just change this to 8000, and I wanted to before, but that there's no big deal. I'm just going to build that image again. Let me confirm that I have saved this, and I have saved this, right? So you can build multiple images. So the network is really messing up. Build this particular application, targets, Danny, Tomiwa, ML app, right? So let me call it duration. Prediction. In fact, let me call it version 1, because I didn't tag that one version 1 before, so I'm just going to tag this particular image version 1. Okay. So it's supposed to be the same, not space. So yeah, let me check that I have that image currently on my system. yeah, Danny Tamiwa version 1, 620 MB. So what I'm going to do is that I am going to run that particular Docker run, and I'm going to port forward the containers port that I'm exposing. I'm exposing port what on this container? I'm exposing port 8000. So I'm going to port forward that port to my own local host on, say, let's say I want to check this thing on 9696, right? Port forwarding 8000, and then I have Danny Tomiwa duration app. Was it duration app I called it?
Duration app.
Is anybody
Duration
following me?
app.
I think it's
Duration.
duration prediction.
Let me just confirm. I don't like that this thing. I don't know if you guys can see this glitch. It's the network that is causing it. So Docker images. So it's called duration prediction version 1. So let me just copy it. Thank you for that. So Docker run -t minus p, because I'm port forwarding. I'm port forwarding to 9696 on my own local host from 8000 that is running this application on the container, and I'm specifying that particular container, and it is what version 1, right? So now my Docker container is running. It is telling me that it is running on this, and it is running on this particular port. So if I want to check it, I will need to go to my local host again to see if that particular endpoint has been exposed. So local host, I think I'm running, I port forwarded it to 9696, right? It's not going to run because I didn't port forward 9696 in my, this that I'm doing right now. If it's not going to be too complex for you, is that I am port forwarding from my, I told you I'm not working locally. I'm running using a GCP VM. So I'm using VS Code to port forward from that 9696 VM to my own local container, to my own local computer. But if you are running on your computer, you won't have to do this. If you're running on your own normal system, all these things I'm doing, you won't have to do this. But if you are running using a GCP VM or any other VM, Azure, AWS, you will have to port forward from that particular VM to your own local host. So I'm just going to add this port 9696 and go and check this again. So there it is. It is running, which means that I can send requests to it. Let's move fast because we are behind schedule, way behind schedule. So now that we have our Docker container, we are going to deploy it on a Kubernetes cluster. So what does that really mean? First of all, if you're in the data engineering track, there are some things that you must have been reading. Okay, before we do that, actually, sorry, I told you we built this image, and before I can pull an image into a Kubernetes cluster to be running as a container on the cluster, I need to push that image that I have built to a Docker Hub registry. Because right now, all this image, I think I ran these Docker images right here. This image that we have right here is not anywhere. It's not available to anybody. But I will make it available to anybody that wants to pull this image. Anywhere that you guys are, if you are following me and you have Docker installed, you can run Docker pull or Docker run this particular image now, and it will run on your system. But it's not going to run yet, except I push it to my own Docker registry. Like I said, it's like a repository for images. So what I'm going to do is, before you can do Docker push like this, before you can do Docker push like this, you need to do Docker login. But since I have already logged in before, it says login consisted and succeeded. But if you have not logged in before, you need to provide the same credentials that you created your Docker orb account with here, and then it's going to log you in. So then you're now going to be able to say Docker push Danny. I think we have Danny Tomiwa, right? ML app. I'm sorry. Duration prediction version 1, right? I think that is right. Docker push. So it's going to push that image from your local computer into the registry. And this is very important if you want to make your image available to anybody. You can also make the image, you can make that particular image private if you don't want it to be a public repo. But all of my images that I have here, they are public images that you can pull. So is it done? It's not. Okay, yeah, it is done now. So let me just continue here. The same thing. I'm still on that system. So let me change to the root directory. Doesn't matter. Yeah, we said we started Minikube, right? So let me see the status of Minikube. Minikube status. It is running on everything is running Kubernetes API server. So I can, when you have your image, you have to deploy your image on a Kubernetes cluster. It has to run on a pod. I'm sure data engineers must have read in their material that the smallest abstraction on a Kubernetes cluster is a pod. So what happens in a pod is that a pod is another abstraction that is running your container. Now, a pod can run multiple containers, but the least that we can have in a Kubernetes cluster is a pod. So now I can do a kubectl get pods for my Minikube cluster that I have right now. No resources found in the default namespace. And I explained what a namespace is. So right now, if I want to deploy this particular pod, I can create a deployment object in a Kubernetes cluster. So I'm going to say kubectl create deployment. What should we call our deployment? We can call it duration app, right? And then the image that we want to use for this particular deployment in our Kubernetes cluster is going to be Danny Tomiwa. It was with duration prediction, right? I think it was duration.
Yes, please. Does duration prediction.
Duration
Version 1.
Yeah, prediction version 1. Right? So there's problem. Create deployment. The fact that this thing is Okay. I'm coming. Let me do something. It's not supposed to matter, but I'm going to delete all of these images that, since I already put it to the Docker hub, Docker remove image, Docker remove image, guys. So, Docker images. One is still running in the background, Docker PS -a. This is still running in the background, so let me stop it. Let's say Docker. Okay, that stopped. So let me remove it. Docker images. I have this image still here. I don't want it again. Still being used. Docker PS -a. Can use this to remove it. Stop that particular image. Okay. Check Docker images again. Is it still running? It's not running.
No, it's not.
Oh, I need to remove that particular container. This is just to show you different commands and removing images and all of that anyways. But if you have a container still running, even after stopping it, it will be running in the background, and you have to stop it before you can remove it. So Docker remove, I'm removing this particular container now. So Docker remove image. I'm going to remove this particular image now. Yeah. So Docker images. Okay, that's gone. So I was trying to do something initially. Coming to CTL to interact with my Minikube cluster, get deployment. We don't have any deployment. Minikube status is running, right? Okay. So okay. The image name is Danny Annual okay, come. I want to come. Yeah, this is it. Duration prediction. Version 1, right? Okay, sorry, deployments. Oh, I'm coming. I think it doesn't like underscore. Doesn't like underscore. So now I have just that command that I posted here is just to create a deployment from that image. And what that command is going to do is that if I do kubectl get pod now, it's going to create this pod. So it's trying to create a container for that image that I have pushed to my Docker registry, right? So what I have there is, let me see, let me just watch this. I think it must have done this by now. Watch kubectl get pods. Oh yeah, it's running now. So it is running that container on my Kubernetes cluster now. So let me just stop this. That container, that our app prediction that we created here is currently running on the Kubernetes cluster. And it is running as a deployment. Now, what is the deployment? The deployment is a Kubernetes abstraction that creates a replica set. I'm sure we must be familiar with replica sets too. And a replica set is the one that will create a pod, which is why we are saying kubectl get pod right here. And what happens is that now that I created this app on the Kubernetes cluster as a deployment, even if I did not specify it when I was creating it, one thing that deployments do is that if I say kubectl, okay, let me get those pods again. Kubectl get pods, right? If I say kubectl delete pod, this is the name of the pod, right? Copy it. If I say kubectl delete pod, right? It's supposed to delete that pod. But if I say kubectl get pods again, I still have that pod running. That is because the replica set in the Kubernetes cluster is making sure that we have, since I didn't specify, the default is that the replica set will be set to 1. If I say kubectl get replica sets, this is the replica set that was created by that deployment on this Kubernetes cluster. So this replica set that is saying that desired 1, the current 1, ready 1, it is going to keep making sure that our pod is running, which is one of the major advantages of running your application on the Kubernetes cluster, to ensure continuity even if a pod dies. Because pods are created in a way that I said pods run containers, and pods can contain multiple containers. But pods cannot run forever. They are definitely going to die. So if your pod dies, the replica set is going to make sure that your pod is always on, so that our clients, if they are trying to interact with our application that we have deployed, they can always get in touch with it. After creating the deployment, and although this is all great, this particular application that we are running on the Kubernetes cluster right now is limited to the cluster. Let me do something. I said Minikube is running, right? So let me echo, there's an environmental variable that contains the Minikube IP. That Minikube is a single node cluster. What does that mean? It means that everything that we have on our cluster, if you can refer back to your material, everything that you have on your cluster, the API server, the control server, the scheduler, the etcd, all of that, they are running on a single node, and it is the Minikube node. And this is not for I'm explaining this so that we can get the big picture. This is not for deployment purposes. Usually, a node will be a full-blown machine, maybe on AWS, on Azure, and you can have multiple nodes. So you can now have another node that is going to be running your master node and all its other components. So that master node is going to be running all the other nodes, and our application will be deployed on all the other nodes. I don't know if we get what I am saying. Right now, because we are just trying to interact and understand what Kubernetes is, we are running on a single node. So if I do this Minikube Echo Minikube IP, this is the particular port that our Minikube node, that single node, is running on. So to this particular deployment that I have deployed on the Minikube cluster is not available to the outside world. Like I said, if I go to, I think I have stopped all those containers, right? So if I come here now and press, it says it's running, right? If I press local, I think let's just go to 8,000, right? Because that's what we said it is running on. There's going to be nothing there. It might take forever to show that there's nothing there for whatever reason. But there's nothing on 8,000. There's nothing running on 8,000. That's why it's even taking this long. So I don't know why it's not telling me. You should just give me an error or something, but that's not the point. The point is that that particular application right now has been abstracted away from anything that has not been granted permission on Minikube. And that is because Minikube is a single node. So like on a normal situation, it could be that this particular pod is running on a particular node, but then that pod will not be made available to the outside world because we have not set it to be available. To make it available, there is a kube proxy that we can use. So if I say kubectl proxy right now, it is serving a proxy. Now, what this proxy does is that it creates this particular port for access to our Minikube cluster. So now I can actually I can go to, this is running, this port that I have exposed with kubectl running this command, kubectl proxy, has given us access to that Minikube cluster. So let me go here. I don't want to use that because I will have to connect back to my VM. It is still the same machine. I mean, if you're running locally, it could just as well be that you have your VS Code running and you're running on the terminal. So what I'm going to do right now is I am going to check the version of this particular kube proxy using a call command. I'm coming. So what I have here is that 1001 as it is running. What I have here is that I can check the version of that kube proxy API, and it is saying that it is version 1 and all of these other things that we don't really, need right now. What I really want to do is get that particular pod and interact with it. So there is a template for interacting with a pod, and it is a Go template. Although we don't necessarily need that. Instead of going this route, I wanted to use a Go template to show you the name of the pod, but we already know the name of the pod. So instead of doing that, I know that I don't want to keep typing the name of that pod every time. So kubectl get pods, right? This is the name of the pod. It's not something that I can even put in my head, except so I'm going to save that as an environmental variable in my current session on terminal now using export. I'm going to save it as pod name, right? Now put this there. Okay, so if I say echo pod name now, I should get that. oh, sorry, echo and $ pod name. I should get this particular variable that I saved in it. So what I want to do is that I want to call that particular pod that is running. So I'm copying all the commands now so that we can be faster, because I think we have actually spent a lot of time here. You know, this pod name is the name of the pod that is running right now, and I have used kube proxy to use this port to expose my Minikube cluster. So that particular proxy is API, it's the version 1. The namespace that this proxy is running on, I explained namespace at the beginning as a way of delineating different people working on the same cluster. But right now, we just have the default namespace. You can remember that when I was running pods, when I was trying to get pods initially, it was saying that no pod was running on the default namespace. Now we have a pod running on the default namespace that I have saved in this pod name. So this particular address that I have put here right now is going to help me get all the features of that particular pod that is running. It is a pod. This right here that we have here is like a YAML configuration. I'm sure we must be familiar with YAML if we are in the data engineering track. We can see that the app that we are running on this pod is running on this particular IP. It is a duration prediction app. And this is that pod anyways. I have access to this pod now. Why? Because I am proxying that pod here. If I'm not proxying it here, I won't have access to this pod. So now what I'm going to do, because that might not make sense to you guys, what I'm going to do right now is that we are going to actually send the same way that we've been sending requests and checking things on that proxy. So what we have here now is that without pod name, like I said, it's still the previous command, but then now specifying the proxy endpoint that it is the proxy that we're using to expose that particular Minikube cluster. I'm coming. I was expecting to get that the echo pod name. Sorry. Okay, still there. So I do this. Pod. This is saying that it's running on 80. That might mean that we deployed the wrong app here. Okay, let me do something. Like I said, I can still interact with this pod. So I'm going to use kubectl to execute into the pod, because what I was expecting to get from that particular endpoint that I put here right now is that welcome home message. But I'm going to enter it and see what is going on. I'll bash into that particular pod. kubectl. Okay, sorry, I'm just copying it here. So what this command is doing is that we want to enter that particular pod using the bash command, the same way that we are like in this particular environment, we are working with a computer. So I want to bash into the pod. Since it is just that container that is running on this pod, it will take me to that container, and I am bashing into it interactively, and I want to be able to give it input. That's what -ti means. I'm just explaining this. You can check So I am inside that pod right now, and as you can see, I have app here, right? It has taken me to that same directory that I created using the Docker file. I don't know if you understand what I'm saying right now, because I have bashed into that pod. So let me cut. Okay, sorry again. Cut. Predict 6,000. Oh yeah. So what happened is that I was the one making a mistake. Okay. It's still serving on 8,000, and I did not specify that to the proxy. Type no proxy. Okay. I'm coming. I wonder why this is not giving me exactly what I want. I was expecting to see that welcome message here. I might be missing something. Local host 2001 API namespaces, default pods, admin, proxy. Okay. Oops. Yeah. Code. Let me check that my pod is actually running integration of this. Well, I don't know why it is not giving me the message that I want, but let's move on. Instead of troubleshooting forever there. But yeah, like I said, the only reason that we're actually able to do all of this is that I am proxying it. So if I stop this now, I want to be able to have access to that pod again. Now, how do you actually get access to the pod? Because I mean, what's the point of deploying your application on a Kubernetes cluster if it's not going to be made available? There's a way to deploy to make sure or configure your pod to be available on that particular node. And since I already told you that the Minikube node, I think I put that particular command here at some point. Can't find it, but what I want to show is this guy, Minikube IP. So this particular node is running here. Now I'm going to make sure that that node, we are going to open a port on the node for the pod that is running inside the node. Like I said, now we are running all of this using just a single node, which is Minikube. So that particular port is running on a port, and then I'm going to port that particular application that we have packaged to a port on this node IP. Now to do that, I will expose my deployment. So as you can see here, the port that we are interested in for this particular application is what port? Is port 8,000, right? And we are specifying that the type is a node port. With a node port, we can get access to that pod from outside our cluster, from outside that particular node anyways, from outside that particular node. There are different types of exposing a deployment. And what this command is actually going to do for us in the end is that it's going to create a service. Because a service, if we don't make our application a service, then it's just running as a pod and nobody will get access to it. So if we use kubectl expose that deployment name, what do we, okay, before I put this command actually, let me just kubectl get deployment. Okay, yeah, I have that duration app running, and then I'm just going to expose that particular deployment. What's the name of the deployment? It is a duration app, as it is specifying here, and it is, I'm exposing it as a node port so that it will be available outside my node. And then I'm porting this particular 8000 that the app is running on. So that service is exposed. So I can say kubectl get services, right? So I have this service running. This Kubernetes service is our cluster that we have been interacting with since to get access to the API server that is helping us. I know if you are data engineers, you should know what an API server is. Go and check your material again. But the point now is that this particular port that I have port forwarded has been exposed on the 32743 port for my Minikube IP. That Minikube IP that I specified here, this particular IP, we are opening this port for it. That's what that command did for me. It port forwarded that particular app to this port for the Minikube node. So one thing I can do now is I can call local HTTP what do they call it now? Minikube IP on that particular port that it is exposing the service app. And we can see here, right, that it has made that particular application available for us. Is anybody still following me?
Yeah, we are here.
Yes, we are.
All right. So it has made that particular application available for us on that particular port that is exposing on the node. And I'm going to repeat again that we have a Minikube cluster, right? That Minikube is a single node cluster. In a normal situation, we are not going to, in a normal deployment environment, we're not going to have a single node cluster. You will have a cluster in which you have multiple nodes. Nodes are machines, like the machine, this GCP machine that I'm running on, for example. So now, in one of those nodes is the master node that is controlling all other nodes. Now, all other nodes can run pods, right? And those pods die. But if we create an application on those nodes as a deployment, it will create a replica set, which will keep our pods running. But those pods are not available to the outside world. So how do we make them available to the outside world? We configure those pods as, or that deployment as a service. And a service is going, we have different types of services. You can go and check your material again, I'm sure it is there, that you can have a cluster IP service, you can have a node IP, a node port service, you can have, let me check, I think I have it somewhere here. You can have a cluster IP, you can have a node port, you can have a load balancer. Exactly, like if you're in the cloud, the load balancer that is outside all of those nodes, we will make sure that we keep sending requests to those pods, which is the application that will be packaged initially, this particular application using Docker. This application, I hope we understand to some extent what I'm saying. If we don't understand, you can come and watch this video again and rewind this particular part. So now that we have deployed it as a service, and I have shown that it is exposed to us using that Minikube node and the port on that node. Now, in a full-blown situation, the nodes have their own IP. So if we do that, we will be exposing a particular port on those nodes that clients outside and anywhere can interact with. And most cases, you want to be using node port deployment. You'll be using a load balancer deployment so that we can have. Okay, now what happens is that when you have your pod, when you deploy your pod, the Kubernetes cluster assigns a particular IP to your pod. And like I said, pods die. Once a pod dies, it's going to spin up another pod because the replica set is there to make sure that that pod keeps running. Once it spins up another pod, the IP changes. So how are we supposed to have consistency in a situation that maybe we even have a front-end application and a back-end application that are running on pods, and one of the pods for the front-end application just dies, and then it spins up another pod, and the back-end application is not able to send data to the front-end application again. The website dies. That's why we are abstracting it as a service. A service will create a single IP that it will keep checking all those pods that are running, check the ones that are running, and convey or route requests to those pods that are running through that single IP. I hope you understand what I'm trying to say. This is just to help us make sense of all those things. What is all these pods? What's the replica? How does this thing even make any sense? I'm going to jump very fast so that we can just conclude now. One thing that we can also do in our Kubernetes cluster, and the way that we can interact with some of them or give instructions or configure a subset of them is to label them. So we can have labels for pods. Why is saying my internet is unstable? I'm going to put command here now. We have this is a command to describe service name. It's not going to run obviously, but that's because I want us to run kubectl get services to get that service name. It used the name of that deployment as a service name. Like I said, this is the Kubernetes cluster for that Minikube that we are running as a service right now for us to do all these things that we're doing. So I'm going to go back to that code, that command network has gone. Can you guys still hear me?
Sure, go ahead.
So we are trying to describe, okay, I think I have it. Yeah, service name, duration, app. Now we have, this is the label. What this particular code, when we deployed that service and all of that, did is that it created a default label for us using the particular service name. But we can label it ourselves using kubectl label command, label pods command. I don't think I'll be able to do everything that I planned on doing again, because we are still supposed to write a YAML file for our deployment. kubectl label pods, pod name. I think, yeah, that pod, yeah. Yeah, it has been labeled. So kubectl describe that pod that is running our container pod. And let me just use that pod name variable that I created before. reason that I created anything first, please. You can see here that the label that I did just now has been included in the labeling for that particular pod. The version equals to version 1. So what's the function of the labels? Like I said, it's just to be able to interact with a particular subset of all the pods, because in this normal situation, we won't have just one pod running. We have multiple pods running on our node. So like I said, we have just one replica set right now. And what we can do is that we can scale our pod, which is actually where I said we are going to stop initially in the BC that you guys got. So let's scale our pods right now. And I will explain YAML files quickly. So maybe that would be your assignment: create a YAML file and deploy this same application. And it's not like we are going to come back, but you do it for yourself. kubectl, I'll quickly explain YAML files anyways. kubectl scale deployment, the deployment name. So what's the deployment name? I think it was duration. Is anybody with me? Can anybody remind me?
Should be duration underscore prediction, I think.
I think it's duration app actually. So
No, it's not underscore, it should be dash. Dash app, not underscore.
Oh, okay, yeah, thank you. That was why I did not even create it initially. So thank you for that.
Yeah, 24%. What?
So it has scaled it now. Initially, you know, when I said kubectl get pods, we kept getting one. So now if I say kubectl, let's just get replica sets now for all those pods that are running. We have 4 pods now because we have scaled it, saying that okay, the replica should keep it at 4, desired 4, current 4, everything 4. If I delete one of those pods, I want us to do something so that we can observe it. I'm going to delete one of those pods here. kubectl get pods. Now we have 4 running, right? Let me delete this one. What happens is that, hey, what I wanted to do is not watch. I wanted to watch it. Right now, it will have spun it up back. Watch kubectl get pods. So it's going to keep watching it at an interval of 2 seconds. So right here, I'm going to come and delete this pod. And we can see here, oh, sorry, that particular pod that I copied initially has been replaced with another pod with another name. So that's to tell you that it keeps creating another pod for that app. So kubectl deletes this one now, right? And what? Okay. Okay, I didn't specify the resource type. Pod. So it has deleted it. And what we have here is that one of them deleted, terminating, it's going to spin up another one to make sure that we keep having 4 pods, because we have specified in our configuration for replica sets that we always want 4 running. Usually, based on the resources you have for your node that is running all those pods, you can say that you want up to, I don't know, I'm just going to guess, 500 pods running, so that it can keep getting requests from clients and giving them the prediction. And usually maybe we are deploying, we should get something straight. We are deploying our application right now as a microservice. So the way it's going to run is that maybe some particular backend is now going to, from probably a website from the front end to our own service, and then it's going to be able to give it created an abstraction away from that particular app that is consuming our service and us running our full access to our service. We can decide to update our service. We can decide to delete the replica set that I want for this is 4. If I do some kind of rollout and rolling, I'm not going to go through that again. Rollout. It is going to delete some of those pods, and it is going to make sure that the service that we are opening for that application keeps running, even though we are changing the version. So it will make some of the pods available, and some of them, it will be terminating them. Once those ones are available, it will be forwarding requests to those ones, it will delete the other ones, and make sure that our application is always ready. And I'm sure that's one of the features of or advantages of Kubernetes that you must have read. Now, let me just go to what finishes it for us. I actually planned on us talking about config maps and all of that too, but time has gone insanely. So I hope, did we enjoy or get anything from everything that I did? Can I?
Yes, of course. Yes, of course. This is a wonderful session.
All right. Well, now let's quickly. What happens is that now I am using commands, kubectl commands, right, to interact with my Kubernetes cluster to create all of those things in like to create definition for, okay, I want this pod to have 4 replica sets, to have this label, to have all of those things. It is going to be arduous and it's going to be a very great hassle if that is how we are going to keep running or telling Kubernetes to create resources for us. So the best way to do that is using YAML files, YAML configuration files. So what we are going to do now is, let me just change directory to that particular repo. Let's make directory configuration file. So there's nothing in the configuration file, but it has been created for us here. I'm going to create a file, kubernetes.yaml, right? And first of all, what I'm going to do is that, so we still have kubectl get pods. We have all those pods running. Kubectl get deployment. We have this deployment running. David.
Yes, sir.
Okay. Thank you, brother, for still being here. I know this has taken a ridiculous amount of time. If I want to delete this particular deployment right now, what do you think? I mean, it's okay if you don't get it, but I mean, what do you think I should delete? Because I told you, right, that when I delete this pod, it keeps recreating itself. So if I want to delete, you said?
Yes, I am with you.
So if I want to delete all these pods, what do you think I should, what command do you think that is going to be? Or what object do you think I should delete? Because I want us to see all of this.
You delete the duration app itself.
The deployment.
Yes, the deployment.
Because I told
the deployment. Yeah, the deployment itself.
I told you that the deployment creates a replica set, right? And the replica set creates pods. And it's the replica set that makes sure that all the pods are running. So to delete that particular deployment on all those pods, I am going to have to delete this deployment right here.
Yes.
I have a reason for deleting it. Sorry, I didn't specify the resource type. Deployment. I think that should do it. So now if I say kubectl get pods, it's going to be terminating all of them. And eventually we won't have any pods running. I should have said watch, but by now it has deleted everything. You don't have to type again. Okay, still terminating. We have to. Should just put watch actually, but I don't know why it's taking so much time to delete deployment. So let's just go straight to the YAML file configuration. What I'm going to do, instead of typing it from the scratch again, I'm just going to copy one YAML file that I have here, and we are going to edit it for our own use case and use it to deploy our cluster, and then we'll be done for the day. We won't go through config maps, but the whole point of config maps is that when our pods are running and we might have set some environmental variables in our pod in such a way that we want to be able to put those environmental variables while the pods are running. That's what you use config maps for. Config maps and secrets. It is also possible that you're using your application to interact with something that needs authentication. And what do I mean by authentication? You need to provide your password and username and whatever. And usually it doesn't make sense that you just put your password and username in the code. So use config maps and secrets to do that. But right now, okay, let me just confirm that get pods. We don't have any resource in this namespace again. That's what I wanted to confirm. So now we can use a config map to tell Kubernetes to do all these things. That's exactly what config maps are. We are going to name the API version 1. This is according to what you want it to be. We are going to specify that we want it to be a deployment, which is what I deployed initially to create those pods so that they can keep running. The metadata is to specify what type of deployment. You said that the name that we want for this deployment, you can call it duration app, right? We have labels app version 1. Then this one, we can add multiple labels to it. We can say that apart from app, we want app duration version want it to be version 1. The spec selector, this is also to, like I said, labels is for selecting all those things. So we have to define selecting all those pods that we have. So we have to define the labels for selecting them. So like I said, we can have app for duration here. So these are what we can be using to select those particular applications if we want to interact with various pods in our cluster. Then we have the templates, metadata, labels, version 1. The template for our particular deployment. Put the labels again there. The spec, we are going to specify the container. So the name of this container that we want is, let's call it duration container, right? Duration container, image, it is not ML app. If you can remember, I think it's duration underscore prediction, right? Let me quickly check that. Underscore prediction. So it's going to pull that image from Docker Hub, and then the ports that this container is supposed to be running on. What port are we serving on what port are we providing our service? Is
6,000.
6,000, right?
Yes.
Then we are not running config maps now, so I'm just going to comment all of these guys out. So this is the configuration for a deployment on a Kubernetes cluster. We are putting in the YAML file. It's easier than running commands here and there. Now we can also just deploy that as a service immediately. So service, we want it to be version 1. Metadata, we are calling it duration service. Spec type, what type of service do we want? Is it node port service? Is it cluster IP service? Go and check that out, please, to understand how services are provided. It is in your material. I'm very sure about that. Node ports, cluster IP, load balancer, selector, app version 1, app, I think I called it duration. So I'm selecting this particular app to be deployed as a service, port TCP, port 8,000, right? Target port is 8,000. The node port that we want it to be running, say, is 31,000. We can specify that node port that was created. Initially, when we created the service initially, it just puts a particular node port for us. What if that node port is in use by another pod or by another deployment or service? Sorry. So here we can specify that this is the port that we need on that node for deploying this particular service to be available to the client. So I'm just going to save this file now and see ls.
Sorry, I know it doesn't matter, but you have to check the spelling of the name of the deployment. I think you made a little spelling error.
Yeah.
Yes. Duration. Instead of duration, you wanted to.
It actually doesn't matter.
I know.
Because
I know
it's a string, right? It will have just given me that. Yeah, but thank you for that. Duration up. So I think I just saved it. So ls. So I can say kubectl. Instead of typing all those commands one by one, I'll just say apply it as a file, kubernetes.yaml.
I think he has a little bit of technical network issues. But before he comes back, I guess we all enjoyed this session. Yeah, it has been a very wonderful and insightful session. So before he comes back to set up its network issues, do you have any questions? I know the way he was going, it was like a little bit fast. You can always come back to this video on YouTube. Then from there, you run your codes on your own. As you're following the video, you run it along. So that's how you can understand better. And also some of these things you were saying are already on your materials. That's for the data engineers in the data engineering track. So I guess you're still having network issues. So this was a very interesting session. In case you have further questions in the Slack channel, you can drop it or definitely reach out to him and he will answer your question. So, okay, he's back. Daniel, you can unmute. We can't hear you. Please unmute.
Okay. Hello, guys. I don't know what happened to my service initially. Can you still see my screen?
No.
Not yet.
Oh. Should we end it there? Because I feel like time has gone.
Yeah, I think you've actually said a handful, like a lot. So I guess we can end it here, and they can also go back to their materials to see further info from what you said. That's the request, JSON file, and all that. So I guess we just have like time for just one question. Does anybody have a question or not? So we can just wrap it up. Any question?
Yeah, I have a quick question.
Okay.
All right. So we have two methods of creating these services and creating these deployments. So you interact with the Kubernetes cluster using kubectl, and then towards the end you talked about using a YAML file. So in your own recommendation, speaking to Mr. Daniel now, which one do you think is the most efficient, or which one will you prefer to use, or will you advise that we use?
Like I said initially, I was using kubectl to show us the nitty-gritties of how a Kubernetes cluster works. In the normal day of you deploying large-scale applications and all of that, no one has time to be saying kubectl do this to the AI server one by one. So the best one to use is actually the configuration.yami file for defining the features of each one of all those resources that we want to deploy on our cluster and deploy it at once. In fact, it's sad that we did not get there because of time. We could have also used that same file to delete everything at once. So even if you create multiple resources at the same time, including pod, deployment services, what other things can you have? And for different applications, you can delete all of them at the same time using a single configuration file, which is the way it actually works in deployment. So configuration files are the ways to go, is the way to go.
All right, thank you.
Okay, thank you for that question. Like I said, we only have time for one question. Thank you, everybody, for joining us in this interesting session. Thank you very much, Daniel. This was very, very insightful. Really do appreciate it. And I hope the data engineers, they've really enjoyed this session and you've gotten more insights to probably issues you might be having when you were going through the course material. So I really want to appreciate everybody for this session, those joining us on Zoom and also others on YouTube. Thank you very much. We'll be having these sessions also for the data science track. We might be having also for the data storytelling track. Whatever time we have any of these hands-on coding session, we'll always pass the information to you on the Slack channel. And also as a reminder, this stage C is still on. It's going to end September 6th. Then for the DevOps track, you have an extra one that's for your extra lab you'll be doing. So all the informations are on the platform and also on your Slack channel. So thank you very much for this wonderful session. This was a very long one and interesting, up to about 3 hours. So you can always come back to this video. It's on our YouTube channel. Anytime, come back to the video, go along with it slowly. You'll get all the concepts. So thank you very much. This is where we'll call it a day. My name is Ajulo Christian, Assistant Program Coordinator and Data Scientist at Amoye, reaching you from Port Harcourt, Rivers State. Thank you very much for this session. See you next